This video is audio content only. It does not contain any video footage or images. If you are expecting visual content, please be aware. This is intentionally provided in an audio-only format. We recommend listening to the audio rather than watching the screen. Thank you for your understanding. Welcome to this exploration of a profound biological revolution that reshaped the Iberian Peninsula. Today, we journey back to the Bronze Age to uncover the mystery of the steppe pastoralists, mobile herders whose arrival triggered a near-total replacement of local Y chromosome lineages. We'll examine the genetic evidence of this ancient wipeout, the rise of the R1b marker, and why the Basque people remain a unique genetic reservoir. Join us as we reveal how a single migration 4 millennia ago still defines the paternal blueprint of modern Spain. Chapter 1: The Bronze Age Revolution and the Steppe Arrival. For thousands of years, the Iberian Peninsula was defined by the slow, rhythmic life of Neolithic farmers. These early inhabitants had arrived from Anatolia and the Near East roughly 8,000 years ago, bringing with them the revolutionary arts of agriculture and animal husbandry. They were the people of the megaliths, the builders of massive stone monuments and the great tombs found across the Spanish and Portuguese landscapes. Genetically, these Neolithic Iberians were a stable mix of those original Anatolian farmers and the even older Western hunter-gatherers who had survived the Ice Age in the southern refuges of Europe. Their paternal lineages were dominated by Y chromosome haplogroups like G2A and I2, markers that had characterized the male populations of Western Europe for millennia. However, this long period of relative genetic stability was not destined to last. Toward the end of the Neolithic, Europe entered what researchers now call the Stone Age crisis. Archaeological data suggests a significant population plunge across the continent, a mysterious decline that left once thriving farming communities weakened and fragmented. While the exact cause remains a subject of intense study, evidence of early forms of the plague, the bacteria Yersinia pestis, has been found in human remains from this era. This biological trigger may have created a demographic vacuum, leaving the gates of Western Europe open for a new force emerging from the east. This environmental and social instability was compounded by the 4.2 kiloyear event, a major climatic shift characterized by severe aridification. As the climate became colder and drier, the sedentary lifestyle of the Neolithic farmers, which relied on predictable rainfall for crops, became increasingly precarious. In contrast, the mobile pastoralist strategies of the groups living on the vast grasslands of the Pontic-Caspian steppe were perfectly suited for such volatility. These herders, known to archaeology as the pit grave culture or Yamnaya, possessed a suite of technological and social advantages, including the mastery of the horse, the use of wheeled wagons, and a diet bolstered by milk that allowed them to thrive in environments where traditional agriculture failed. Around 2500 BCE, the genetic signature of these steppe pastoralists began to appear in the Iberian Peninsula. This was not a single overwhelming wave of conquest, but a steady infiltration that, over the course of 400 years, resulted in a change so profound that it essentially rewrote the biological history of the region. By the time the Bronze Age was in full swing, the genetic landscape of Iberia had been transformed. The newcomers brought with them a specific genetic marker on their paternal line, the Y chromosome haplogroup R1b, specifically the subclade R1b M269. Before this period, this marker was virtually non-existent in Iberia. Yet, within just a few centuries, it became the dominant paternal lineage. The scale of this replacement is staggering. While the overall ancestry of the Iberian population shifted to include about 40% steppe-related DNA, the Y chromosome replacement was nearly 100%. This asymmetry reveals a deeply gendered turnover. While the mothers and grandmothers of the new Bronze Age Iberians were often local women from the long-standing Neolithic farming communities, their fathers and grandfathers were almost exclusively the newcomers from the East. This period of turnover marks the biggest discontinuity in the history of the Iberian population since the advent of the Neolithic itself. The path these migrants took into Iberia was a multi-generational journey through Central Europe, where they blended with local cultures to form the bell-beaker phenomenon. Named for their distinctive, bell-shaped pottery, these groups became the primary vector for steppe ancestry in Western Europe. In Iberia, this transition is marked by the appearance of Ciempuelo-style pottery, a refined and decorated ceramic tradition that signals the arrival of new social elites. These groups moved along the Atlantic fringe, creating a shared cultural and genetic corridor that linked the Iberian Peninsula to the British Isles. This specific migration route from the Iberian Peninsula to the north is actually preserved in ancient lore. The Irish Book of Invasions tells the story of the sons of Mil Espain, a group of warriors who traveled from Spain to conquer Ireland. For centuries, this was dismissed as mere mythology, but modern DNA analysis has confirmed the biological reality behind the legend. The R1b lineages that dominate the British Isles today are the same ones that established themselves in Iberia during the Bronze Age, confirming a deep and ancient connection between the two regions. As the Bronze Age progressed, the influence of the steppe groups continued to evolve. Later phases of this expansion are associated with the Urnfield tradition, characterized by the practice of cremating the dead and placing their ashes in ceramic urns buried in large cemeteries. This tradition, which spread into the northeast of the peninsula, represented a further consolidation of the cultural and social shifts that began with the first arrival of the horsemen. The arrival of the steppe-related groups coincided with the introduction of bronzeworking and a shift toward more hierarchical, warrior-oriented social structures. The archaeology of this period begins to show a marked increase in weaponry and displays of personal wealth, standing in stark contrast to the collective, egalitarian tombs of the Neolithic. The environmental context of the peninsula played a crucial role in how this replacement unfolded. Iberia's diverse geography, ranging from the humid Atlantic north to the semi-arid Mediterranean south, offered various niches for these new pastoralist strategies. The ability to move herds across the landscape was not just a means of migration, but a permanent strategy for survival and expansion. The steppe migrants are also widely believed to have been the spreaders of early Indo-European languages. As their paternal lineages became dominant, so too did their speech, eventually giving rise to the Celtic and other Indo-European tongues that would dominate the peninsula in later centuries. The result of this migration was a synthesis that formed the basis of the Iberian Bronze Age, characterized by a population that carried the maternal legacy of the ancient megalith builders and the paternal legacy of the horsemen from the east. This genetic revolution was a foundational event that set the stage for everything that followed, creating a substrate that was remarkably uniform in its paternal origins while remaining diverse in its maternal and autosomal roots. This blending of the ancient and the new created a population that was uniquely adapted to the challenges of the Iberian environment, combining the agricultural knowledge of the first farmers with the mobile, resilient strategies of the steppe herders. The speed of this transition remains one of the most debated aspects of the research. In some areas, the turnover seems to have happened in as little as 200 years, which is roughly 6 to 8 generations. Such a rapid shift in the Y chromosome pool without a total replacement of the overall genome suggests a social process where the offspring of the newcomers were significantly more likely to survive and reproduce than those of the indigenous males. This genetic reset of the male line raises profound questions about the nature of the interaction between the incoming pastoralists and the local farmers. Was this a story of peaceful integration and social prestige, or was it a more violent displacement? Chapter 2. The Paternal Blueprint, Phylogeny and the Iberian Signature. To truly understand the genetic landscape of modern Spain, we must look past the broad strokes of migration and zoom in on the specific biological signature that defines the vast majority of its men. This signature is found on the Y chromosome, a piece of DNA that acts as a strictly paternal record, passing from father to son with very little change over thousands of years. While the arrival of steppe pastoralists resulted in a 40% autosomal shift and a near total replacement of the indigenous Y chromosome lineages, the focus here is on the specific genetic phylogeny, the branching tree of descent that allowed a single lineage to become the biological bedrock of the peninsula. The second and far more significant branch for Iberia is RP312. This is the Atlantic lineage, the source of the overwhelming majority of paternal lines in Spain, Portugal, France, and the British Isles. Within the Iberian Peninsula, this branch produced a highly successful son known as RDF27. This mutation, which likely occurred between 4,000 and 5,000 years ago, is the defining paternal marker of the peninsula. It is so prevalent and so specific to this region that it is frequently referred to as the Iberian subclade. The phylogeny from M269 to L11, then to P312, and finally to DF27 represents the biological path taken by the ancestors of most modern Spanish men. This genetic signature is not just a label. It is defined by a specific set of technical markers known as the Atlantic modal haplotype, or haplotype 15. To a geneticist, this haplotype is a recognizable thumbprint on the Y chromosome, characterized by specific allele values at various loci. The classic signature of haplotype 15 includes the markers DYS19 at 14, DYS388 at 12, DYS390 at 24, DYS391 at 11, DYS392 at 13, and DYS393 at 13. When these specific numbers appear together, they signal a lineage that has its roots in the rapid expansion of the Bronze Age Atlantic fringe. This biological record is so stable that these exact markers can be traced back through thousands of years, linking modern men to the very first pastoralists who brought the R1b lineage across the Pyrenees. The dominance of this R1b blueprint becomes even more apparent when contrasted with other historical layers of the Iberian paternal landscape. For example, the Y-DNA profile of Sephardic Jews represents a completely different genetic trajectory, reflecting a Mediterranean and Levantine history rather than the steppe-derived Atlantic one. In Sephardic populations, the paternal landscape is dominated by haplogroup J2 at 25% and J1 at 22%, with smaller contributions from E1b1b at 9% and haplogroup T at 6%. In these communities, R1b often accounts for only about 13% of the population. This contrast highlights the fact that while Iberia has been a crossroads for many peoples, the R1b P312 lineage remains a distinct and massive biological substrate that was established long before the arrival of later Mediterranean civilizations. The legacy of this era is also written in the functional biology of the population. While the Y chromosome tells the story of the fathers, the broader genetic environment created during this period of synthesis includes protective traits that have persisted for millennia. One such example is the mitochondrial lineage H3. While maternal lineages showed much higher continuity during the Bronze Age transition than paternal ones, the expansion of certain subclades like H3 became a hallmark of the Western Mediterranean. Modern research has revealed that this specific genetic signature is not just a neutral marker of ancestry. It carries significant biological implications. Specifically, the H3 lineage has been identified as being highly protective against AIDS progression, a remarkable example of how ancient genetic shifts can influence the health and resilience of modern populations in unexpected ways. This biological trajectory, from the branching of the R1b tree to the stabilization of specific haplotypes and protective mutations, created a population that was genetically unified in its paternal origins. The transition from the diverse Y chromosome markers of the Neolithic, such as G2A and I2, to the near monopoly of RP312 and RDF27 was a fundamental resetting of the Iberian biological clock. It established a blueprint that would remain the dominant theme of the peninsula's history, even as new languages, religions, and empires rose and fell. As we look at the technical precision of these markers and the specific branching of the R1b tree, we are left with a profound question regarding the mechanics of this change. If the RDF27 mutation was just one of many that occurred during the Bronze Age, what were the specific social and environmental conditions that allowed this one branch to grow so large that it eventually shaded out almost every other paternal lineage in the peninsula? Chapter 3. The Mechanics of Male Replacement. The central mystery of the Iberian Bronze Age is not that a migration occurred, but the sheer, lopsided efficiency of its outcome. While the overall genetic makeup of the peninsula shifted to include roughly 40% ancestry from the newcomers, the paternal lineages were almost entirely overridden, leaving a nearly total replacement of the Y chromosome. This stark asymmetry suggests that the transition was not a simple blending of two equal populations, but a process that specifically targeted or marginalized the indigenous male line. To understand how such a total biological reset occurred in just a few centuries, we must investigate the specific sociological and biological models that explain how a minority of men could effectively erase the genetic legacy of an entire region's fathers. One of the most compelling statistical anchors for this shift is the discovery of a massive reproductive bottleneck that occurred across Eurasia during this period. Genetic analysis of modern and ancient genomes has revealed that the effective male population collapsed to a staggering ratio of just one reproducing man for every 17 women. This 1:17 bottleneck indicates a society where reproductive success was not distributed evenly, but was instead concentrated in the hands of a very small, dominant elite. In the context of the Iberian Peninsula, this suggests that the incoming men associated with the R1b P312 lineage, also known as RS116, did not just arrive. They established a social system that allowed a tiny number of their lineages to monopolize the next generation. This concentration of reproductive power is often explained through the lens of social dominance and the warrior ethos. The archaeological shift from the collective, egalitarian burials of the Neolithic to the individual, hierarchical graves of the Bronze Age points toward a society that had become increasingly stratified and violent. While large-scale battlefields are rare in the early transition, the cultural evidence of a more aggressive social order is undeniable. Later discoveries in the region, such as the find at Ulastret, where 40 severed heads were discovered with large nails hammered through them to be displayed as war trophies, illustrate the brutal reality of the society that eventually emerged. This was a world where status was tied to martial prowess and the ability to command resources, a far cry from the communal structures of the megalith builders. However, the replacement of an entire male population does not strictly require a peninsula-wide massacre. Mathematical modeling of population dynamics offers a more subtle yet equally powerful explanation. Researchers have demonstrated that a very small difference in reproductive rates can lead to a total genetic turnover in a surprisingly short amount of time. If the incoming groups had a reproductive rate of just 2.02 children per person, compared to a rate of 1.98 for the local population, the newcomers would achieve a 90% replacement of the original population in just 12 generations, roughly 200 to 300 years. This demographic pressure model suggests that the steppe-derived men didn't necessarily need to kill their rivals. They simply needed to outcompete them socially and biologically. The technological advantages of the newcomers, specifically their mastery of the horse and their cattle-based economy, were the primary drivers of this reproductive edge. In a world where food security was volatile, the ability to move wealth in the form of livestock provided a level of resilience that sedentary farmers lacked. This mobile wealth could be concentrated and inherited, allowing powerful patriarchs to support multiple wives or command preferential access to local women. In such a system, the sons of the elite would inherit the same advantages, creating a compounding effect that allowed the R1b lineage to expand exponentially, while the lineages of marginalized Neolithic men, who lacked the same social prestige or resources, slowly faded into biological obscurity. Beyond social and economic factors, a fascinating biological theory known as Haldane's rule provides an alternative explanation for the vanishing Y chromosome. This theory focuses on immune system incompatibility between diverging populations. It is possible that when the steppe-derived men and local Neolithic women began to have children, a biological conflict arose. If a mother's immune system perceived a male fetus carrying a foreign Y DNA as a threat, her body might have attacked the fetus, leading to a higher rate of miscarriage for male offspring of mixed unions. Over several generations, this biological bias against the indigenous Y chromosome, or even against the hybrid male offspring, could lead to the rapid extinction of a paternal lineage without the need for a single spear being thrown. This gendered replacement is further illuminated by the way property and kinship were structured. In the patriarchal systems of the steppe, kinship was traced strictly through the male line, and property was often inherited by the eldest son. This created a demographic engine where younger sons, left without a significant inheritance, were driven to seek out new territories and establish their own lineages. When these mobile groups of young men entered the Iberian Peninsula, they likely established themselves as a new ruling class. By integrating local women into their social structure while excluding local men from the same levels of status and wealth, they ensured that only their paternal signature would be passed down to the future. The transition was also bolstered by the biological advantage of lactase persistence. The ability to digest milk into adulthood provided a high-calorie, year-round resource that made the newcomers more resilient to seasonal food shortages. This metabolic edge likely translated into lower infant mortality and higher overall health for the children of the steppe-derived groups. As their population grew more rapidly than that of the local farmers, the sheer weight of their numbers would have exerted a steady pressure on the landscape, eventually overwhelming the indigenous social structures. The investigation into these mechanics reveals that the wipeout was likely a combination of these factors: a social system that favored a small number of elite males, a demographic model where a slight reproductive advantage led to rapid replacement, and a biological environment where the newcomers were simply more resilient. The result was a total reconfiguration of the Iberian paternal landscape, a biological reset that turned the peninsula into a stronghold for the R1b lineage. This was not a random event, but the result of a specific set of social and biological strategies that were designed for expansion and dominance. As we look closer at the archaeological record, we see that this was not just a change in DNA, but a fundamental shift in the human experience. The transition from the collective to the individual, from the farmer to the pastoralist, and from the community to the lineage created a new social reality that would define the peninsula for millennia. The question that remains is how this new, genetically unified population began to organize itself into the distinct tribal identities that would eventually face the might of Carthage and Rome. Chapter 4: The Iron Age Reservoir. For generations, the Basque people of the northern Pyrenees have stood as the ultimate enigma of European anthropology. Tucked into the rugged valleys of northern Spain and southwestern France, they speak Euskera, a language that shares no roots with the Indo-European tongues that dominate the rest of the continent. This linguistic isolation long fueled a romantic scientific myth, the idea that the Basques were a living fossil, the last unmixed descendants of Paleolithic hunter-gatherers who survived the Ice Age untouched by the migrations that reshaped Europe. It was a compelling vision of a people frozen in time, a genetic island in a shifting sea. However, recent breakthroughs in ancient DNA research have replaced this myth with a story that is more complex and arguably more fascinating. While the Basques were once viewed as a pristine control group for the ancestral European gene pool, modern genomic analysis suggests a necessary scholarly caution. Because of their long-term isolation and small effective population size, the Basques have experienced intense genetic drift. This makes them a specialized outlier rather than a perfect representative of the original European inhabitants. They are not a window into the Paleolithic, but rather a unique biological outcome of the Bronze Age. The Y chromosome data from the three primary Basque provinces, Álava, Guipúzcoa, and Vizcaya, provides the clearest evidence of this reality. If the Basques were truly Paleolithic remnants, their paternal lineages would be dominated by ancient European markers like I2 or G2A. Instead, modern Basque men carry the Y chromosome haplogroup R1b at staggering rates. In Guipúzcoa and Vizcaya, this frequency exceeds 87%, while in Álava it remains at 75%. This is the same R1b M269 marker brought to the peninsula by steppe pastoralists 4.5 millennia ago. The paternal ancestors of the Basques were not the original hunter-gatherers of the Pyrenees. They were the same horse-riding herders who transformed the rest of Iberia. This creates the Basque paradox. How did a population undergo a nearly total replacement of its male genetic line while successfully clinging to a language that predates the arrival of those very migrants? In almost every other part of Europe, the spread of R1b is synonymous with the spread of Indo-European languages. Yet the Basques remained linguistically defiant. This suggests a social dynamic where incoming steppe-derived men were integrated into local structures that prioritized the transmission of the indigenous tongue. Perhaps the social fabric of these mountain communities was centered on maternal lines or communal traditions that proved more resilient than the biological lineage of the fathers. The timing of this genetic shift has been pinpointed through the study of mutations in the RS116 lineage. Geneticists have estimated the age of the most recent common ancestor for Basque men with remarkable precision. In Vizcaya, the mutation is approximately 4,500 years old. In Álava, it is roughly 4,000 years, and in Guipúzcoa, about 3,700 years. These dates align perfectly with the Bronze Age transition seen elsewhere in Iberia, confirming that the steppe expansion reached the remote northern mountains at the same time it was sweeping through the central plains. What truly distinguishes the Basques is not the absence of steppe ancestry, but their subsequent isolation. While the rest of the Iberian Peninsula was transformed by Roman, Germanic, and Islamic migrations, the Basque country remained a genetic reservoir. They are essentially an Iron Age population preserved in the amber of their genography. They carry the genetic signature of the peninsula as it existed 3,000 years ago, before the arrival of the Mediterranean and North African influences that define modern Spanish and Portuguese genomes. This isolation is visible in more than just DNA. It is corroborated by non-DNA genetic markers, most famously the exceptionally high frequency of the Rh-negative blood factor. This classic Basque association, documented as early as the mid-20th century, serves as a physiological record of long-term endogamy. While the rest of Iberia became a cosmopolitan mosaic, the Basques avoided the genetic blending of the Roman and Moorish periods. In the south and west of Spain, North African-related ancestry can reach 10%, but among the Basques, this signal is nearly zero. They also show almost no genetic influence from Germanic tribes like the Visigoths. This long-term isolation led to a phenomenon known as genetic drift, where certain markers became highly concentrated. The RDF27 subclade of R1b reaches its absolute global peak in the Basque Country, accounting for over 60% of the male population. This is a classic founder effect. The Basques are not different because they possess older genes. They are different because they possess a highly concentrated version of the lineages that were common across the entire peninsula 4,000 years ago. Even within the Basque Country, there is a small but significant internal genetic structure. Research indicates a 1.71% variance between provinces, a lingering mark of ancient tribal divisions. These subtle differences reflect a world where each valley was its own universe, defined by deep ties to the land and a fierce sense of local identity. This internal diversity is a testament to the long history of these communities in their mountain home, written in the variations of their R1b lineages. The maternal line offers a complementary story of deep-rooted continuity. While the male line was replaced, the mitochondrial DNA of Basque women shows some of the highest frequencies of ancient European haplogroups on the continent. Subhaplogroups like H1 and H3 reach their local peaks here, with H1 encompassing nearly 28% of maternal lineages and H3 representing about 14%. This maternal anchor is the true link to the ancient past. It suggests that while the fathers of the Basque Bronze Age were newcomers, the mothers were the daughters of the inhabitants who had lived in those mountains for 10,000 years. The Basques were not culturally isolated during this transition. They were active participants in the broader movements of the era, including the adoption of the Urnfield tradition. This Central European cultural package, characterized by specific pottery and cremation rituals, spread into the northeast of the peninsula. The Basques adopted the culture and the technology of the Urnfield groups, but rejected their language, a rare feat of cultural selective pressure. They took the tools of the New Age while keeping the voice of the Old. Before they became isolated, the Basques were part of a vibrant maritime network. Y chromosome markers show a close affinity between Basque populations and those of Ireland and Gascony. This Atlantic connection suggests that the Bronze Age expansion of the R1b lineage followed a maritime route along the coast, linking the northern mountains of Spain with the British Isles. These groups were part of a shared seafaring world, defined by a common paternal heritage and a mobile culture. It was only after this initial expansion that the Basque drawbridge was pulled up. The geography of the Pyrenees and the Cantabrian Range played a crucial role in maintaining this state. The narrow, steep valleys are ideal for pastoralism, but difficult for military conquest. During the Roman period, the region remained on the periphery of the empire. The Romans were interested in fertile valleys and mines, not rugged mountains. This pattern of benign neglect allowed the Basques to preserve their Iron Age genetic profile long after it had been overwritten elsewhere. The same was true during the Islamic period. While Muslim expansion reached the northern mountains, the occupation was never as permanent as it was in the south. Consequently, the North African genetic influence, so visible in Andalusia and Portugal, is absent here. During the Reconquista, the Basques were a source of migrants moving south, but they received few in return. This one-way flow solidified their role as a genetic reservoir for the peninsula's foundational Bronze Age and Iron Age structure. This singular history has made the Basques a subject of intense interest for medical geneticists. The long-term effects of genetic drift and a lower effective population size have resulted in lower overall Y chromosome diversity. This is not a sign of purity in a romantic sense, but a biological record of a population that passed through a genetic bottleneck and remained closed to outside flow for millennia. It allows researchers to use the Basques as a reference point to measure the impact of later migrations on the rest of the Iberian population. The Basque story is a living refutation of simple historical narratives. They are not the Paleolithic relics of legend, nor are they products of the later Mediterranean world. They are a population that absorbed the shock of the Bronze Age and then maintained that specific genetic and linguistic synthesis for 4,000 years. Their Y chromosomes tell a story of migration and replacement, while their language and maternal DNA tell a story of endurance. By studying the Basques, we are not just looking at a local exception. We are observing the foundational processes that created the modern European population. They are the guardians of a genetic and cultural heritage that has largely vanished elsewhere, a reminder of the diverse ways in which human populations respond to the pressures of migration. The horsemen of the steppe found their way into every valley of the Pyrenees, leaving a mark that would be shielded from the later layers of history by the very mountains that had once been their final frontier. This leaves us to wonder, if the northern mountains could preserve such a specific profile through the rise and fall of empires, what other echoes of the Bronze Age might still be hidden in the remote corners of the continent, waiting for the next breakthrough in ancient DNA to bring them to light. Chapter 5. The Resilient Lineage, Historical Continuity, and Ecological Legacy. The genetic map of the modern Iberian Peninsula is a testament to the enduring power of a single demographic event. While the history books focus on the rise and fall of empires, the Romans, the Visigoths, and the Moors, the biological reality of the Spanish male tells a story of remarkable stability. When we examine the Y chromosome profiles of man across the peninsula today, we find a staggering level of uniformity. Statistical analysis reveals a reduced Y chromosomal interpopulation variance of just 1.2% across the mainland, a figure that underscores how thoroughly the Bronze Age expansion of steppe-related groups homogenized the paternal landscape. This biological foundation has proven resilient against every subsequent wave of migration and conquest for over 4 millennia. This dominance was not inevitable, nor was it the result of a complete lack of outside contact. Archaeological evidence has recently uncovered a fascinating outlier that challenges the idea of Iberia as an isolated fortress before the Islamic conquest. Near Madrid, researchers discovered the remains of a 4,000-year-old man whose genetic profile was primarily North African. Buried in a culturally typical way for the region and period, this first-generation immigrant proves that North African contact occurred sporadically long before the Middle Ages. Yet, despite such early arrivals, these lineages did not take root. The paternal structure established by the R1b carrying pastoralists was already so entrenched that these early outliers remained just that, isolated individuals who left no lasting mark on the paternal gene pool. The specific archaeological marker of this successful expansion is the Cienfuegos style of bell beaker pottery. These refined, decorated ceramics are found in the burials of the early RP 312 elites, such as the famous find at El Hundido. This pottery represents more than just a change in aesthetic taste. It signals the arrival of a new social order that prioritized the RP 312 lineage. By the time this style became widespread, the paternal reset was largely complete, establishing a genetic monopoly that would survive the arrival of the most powerful empires of antiquity. The Roman period is often cited as the most transformative era in Spanish history, bringing a new language, law, and religion. While the Roman presence introduced a discernible autosomal shift, contributing roughly 1/4 of the overall genetic profile of modern Spaniards through migrations from Italy and the eastern Mediterranean, it failed to displace the RP 312 paternal line. The local men carrying this marker were not replaced, they were integrated. They became Roman citizens, soldiers, and administrators, but they continued to pass on the same Y chromosome that their pastoralist ancestors had brought across the Pyrenees. The Roman Empire changed how these men lived and spoke, but it did not change who their fathers were. This pattern of cultural change without paternal replacement continued through the Germanic migrations. The Suebi and Visigoths established kingdoms that lasted for centuries, yet their genetic impact was minimal. The true test of the RP 312 foundation came with the Islamic conquest in 711 CE. 8 centuries of Muslim rule in Al-Andalus introduced significant North African and Eastern Mediterranean ancestry. However, the modern distribution of this legacy defies simple geographical logic. Contrary to historical expectations that the southern heartlands of Al-Andalus would retain the highest levels of Moorish genetic influence, North African markers are often found at higher frequencies in the west and northwest, such as in Galicia and Leon, than in the southern regions. Despite these autosomal contributions, which average roughly 5% across the peninsula, the paternal RP 312 line remained the overwhelming majority. Even significant historical minorities, such as the Sephardic Jewish community, were eventually integrated into this dominant paternal structure, their own distinct lineages becoming small threads in a much larger R1b-dominated tapestry. The survival of this ancient lineage was not a passive process. It was actively reinforced by the Reconquista. This centuries-long movement of Christian kingdoms from the north to the south acted as a second wave of RP 312 expansion. As the northern populations repopulated the southern plains, they effectively reset the genetic complexity that had developed during the Middle Ages. This process was so thorough that it erased much of the paternal diversity introduced during the Islamic period, explaining why the southern regions often show less North African influence today than the northwestern pockets that were less affected by these massive organized repopulation efforts. This genetic convergence re-established the Bronze Age foundation as the primary paternal signature of the entire country, explaining why a man in Seville today shares more paternal ancestry with a man in the northern mountains than with his historical predecessors from the era of Al-Andalus. The resilience of the RP 312 line is also physically etched into the Spanish landscape through the social and ecological structures introduced by the early pastoralists. Spain remains a country defined by its relationship with livestock, with nearly 90% of its land capable of serving as pasture. The ancient mobile herding systems brought by the steppe groups evolved into sophisticated networks that maintain the land to this day. The most visible manifestation of this legacy is the network of cañadas reales, legally protected drove roads that stretch over 125,000 kilometers across the peninsula. These were the highways of the pastoralist world, facilitating the seasonal movement of millions of animals. This pastoralist infrastructure is not merely a relic of the past, it is a functioning ecological engine. The impact of these mobile herds on the Spanish environment is profound. Each sheep moving along a drove road acts as a biological engineer, transporting an average of 5,000 seeds and fertilizing the land with 3 kilograms of manure every single day. This constant movement of nutrients and genetic material across the landscape created the dehesa, the open forest grassland system that covers millions of hectares. The dehesa is a human-made ecosystem, a monument to a way of life that prioritized the herd and the lineage. The knowledge required to manage these complex systems was passed down through generations of herders, reinforcing a patriarchal social structure where wealth and identity were inextricably linked to the male line. This social environment served as the perfect incubator for the preservation of the RP 312 lineage. In the traditional transhumance systems, shepherds would spend months away from home, moving between summer mountain pastures and winter lowlands. This specialized, often dangerous work created a distinct cultural group with its own hierarchies and traditions. The prestige of livestock ownership and the control of mobile resources ensured that the successful herder, and by extension his paternal lineage, would thrive. The success of the herd was the success of the father, a dynamic that allowed the RP312 marker to maintain its dominance through periods of extreme political and social upheaval. A modern parallel to this ancient turnover can be seen in the genetic history of the Canary Islands. During the European colonization in the 15th century, a sharp, sex-biased replacement occurred that mirrors the events of the Iberian Bronze Age. The indigenous Berber paternal lineages were rapidly substituted by European RP312 lines, while the indigenous maternal lineages survived in much higher proportions. This historical event provides a clear template for how a technologically mobile group of men can effectively overwrite a local male population while incorporating the female population, leaving a permanent mark on the paternal gene pool that persists long after the initial conquest. The regional variations in RP312 frequencies today provide a high-resolution map of these historical layers. While the Basque Country serves as a point of comparison for the almost total lack of later Mediterranean or North African admixture, the rest of the peninsula shows how the foundational lineage has branched and adapted. In the northeast, Catalonia maintains an RP312 rate of over 80%, while in the south, regions like Andalusia West show lower but still dominant frequencies around 54%. These variations are the result of the interplay between the foundational Bronze Age replacement and the second wave of the Reconquista, which smoothed over the genetic peaks and valleys of the Middle Ages. The stability of this foundation is also evident in the way it shaped the linguistic and cultural boundaries of the peninsula. The fact that the RP312 lineage is found in both Indo-European and non-Indo-European speaking regions proves that the genetic foundation was laid before these linguistic identities were fully solidified. The pastoralist expansion created a biological unity that transcended the cultural diversity that would later define the different tribes and kingdoms of Iberia. The horsemen of the steppe did not just pass through the peninsula, they became the peninsula, establishing a genetic and ecological bedrock that has remained unshaken for 4,000 years. As we look at the frequency of different markers across the subregions of Spain, the data tells a story of overwhelming biological success. The RP312 lineage is the common denominator of the Spanish male experience, a silent, permanent monument to the men who crossed the Pyrenees and claimed the future of the land. This enduring legacy is a powerful example of how a single demographic event can redirect the biological course of an entire region, establishing a foundation that remains as stable today as it was at the dawn of the Bronze Age. The physical structure of the land, from the drove roads to the dehiscus, continues to support the way of life that first allowed this lineage to flourish. The genetic history of the Iberian Peninsula reminds us that the story of a people is often written in two different books. The autosomal and maternal records tell a story of continuity and the slow blending of ancient populations. But the Y chromosome tells a story of sudden shifts and the enduring power of a single successful lineage. In Iberia, the Book of the Father was rewritten in the Bronze Age, and that version of the story has remained the dominant one, surviving every challenge that history could throw at it. The movement of people from the north into the south during the later medieval periods only served to reinforce this ancient pattern, ensuring that the paternal signature of the steppe herders would remain the defining feature of the Iberian male population. This leaves us to consider how much of our modern identity is truly our own, and how much is the silent echo of an ancient revolution that never truly ended. The story of the Iberian Bronze Age is a testament to the enduring power of a single demographic shift. Through the near-total replacement of indigenous paternal lineages by steppe pastoralists, we see how social prestige, technology, and ecological adaptation can rewrite the biological history of a region. This R1b signature did more than survive. It became the bedrock of the peninsula, resilient against the rise and fall of Rome and Al-Andalus alike. These findings remind us that history is not only found in ruins, but is etched into our very cells. The Iberian experience reveals how ancient migrations continue to shape modern identities and social structures, leaving us to wonder what other silent revolutions are still waiting to be uncovered within the human genome. Thank you for listening.